Hello, we'll be continuing with surface areas and volumes. We are now into surface area of right circular cylinder. Earlier we had had a few sessions on cuboid. Let's note down the formula for the right circular cylinder. I'm drawing a right circular cylinder. So you might not look accurate though. This is the radius and this being the height of the right circular cylinder. When we talk about the lateral surface area, that means we are not talking about these two portions, it's only about this part. So I'll name this as H, this as R. When this is one we are taking, it's not a hollow cylinder first of all. So this is also R. The lateral surface area or the curved surface area, we can come across that term as well. I'll just write it. Curved surface area is given by 2 pi RH. That will be given in square unit obviously. And then each of this area which we have to calculate, they are the circular part, so will be each base can then be calculated as pi r square, and the total surface area then becomes 2 pi total. I'll just write total surface area is 2 pi r square or 2 pi rh plus 2 pi r square, or you can remember it as 2 pi r plus h. If you take 2 pi r common from this, first I have written h plus r or r plus h, whatever you wish to. As because I have written it there, I'll just modify this and name it as h and r. Oh god, sorry. H and r. Okay. Now when it is a hollow cylinder, that means there is a kind of I can just draw one more here to show how it within. That means the part, I'll just be joining this to make a kind of a cylinder inside. That means this blue part which I have drawn, there is nothing there, so only we are dealing with this part of the cylinder, and that is a solid one. In that case, if it is a hollow cylinder, obviously the formula will change. In that case, each base area will be area of this whole outside circle minus area of this inside circle. That will give us area of this portion. That is the area of the base. This one, I tell you, this whole pink portions. And that will be calculated as, I'll just write down here. Let's make R. This is the lateral surface area when it is a hollow cylinder. So thereby pi r square minus pi small r square. This r is representing the radius of the outside circle, the exterior one. And now if I take a pi common, it will be pi r square minus r square. Similarly, oh, I made a mistake. This is not the lateral surface area. This is the base area. Area of each base actually. Base area. What about the surface area then? Curved surface area. Again, it will be on the similar tone. It will be external surface area minus the internal surface area. I'll just write here the lateral surface area will then be external surface area will be calculated as 2 pi capital R as we have been taken. So it is 2 pi RH, and that way if I take 2 pi H common and R minus R will be left with it. The same thing will also follow with the total surface area case. In that case it will be the area of, I'll just write here, total surface area is given by 2 pi RH plus 2 pi RH, that's a small one, plus 2 pi and capital R square minus small r square. Now once we get into the application of these formula, that will be easier for us to understand, and then you'll see that automatically you have remembered all the formulas, so you don't have to bother more about how to remember this and the whole of formulas. I'll take the first question. Says an iron pipe which is 20 centimeter long has exterior diameter equal to 25 centimeter. If the thickness of the pipe is 1 centimeter, find the whole surface. Oh, I made a mistake again here. It's a typing mistake, so kindly ignore it, that if at all I don't get to locate it. Total surface area, this seems to be a hollow one, because a pipe would be a hollow one from inside. We have to find the total surface area. If you remember, we had just noted down the formula. I'll write that again here to find for our application. It is 2 pi r 2 pi r h plus 2 pi r h plus 2 pi r square will also be then r square minus r square. In this case, I can take a 2 pi h common, and that will leave us with r plus r. So plus 2 pi r square minus r square. Let's see what's the information given. An iron pipe, that is the height is given to be 20 centimeter, and right here the information given. Right, external diameter equals to 25, so the radius becomes 25 by 2, that's 12.5. so capital R is 12.5 centimeters. If the thickness of the pipe is 1 centimeter, that means the internal radius will be 12.5 minus 1, so it is 11.5 centimeter. That's the thickness. So we'll get, once we subtract 1 centimeter from the external radius, we will get the internal radius. Now I'll simply apply this in the formula. If 2 into, I'll replace it, substitute it with 22 by 7, h is 20. The internal, if I add this 12.5 and 11.5, it will be 24. I can remove this bracket and put up a multiplication symbol there, plus again there is a 2 pi, so it is 2 into 22 by 7, and in the bracket it is r square is 12.5 square minus 11.5 square. So I'll just do it. 11.5 square is 132.250, and 12.5 square will be 156.25. then if we subtract, that's giving us 24. So I'll write here a 24. Let us solve this part. I can take a 2 into 22 by 7 common. That will leave me with, I can also take a 24 common as well. That will leave me with 20 plus 1, so it is 21. That is 2 into 22 by 7 into 24 into 21. So now it has come down to 24 into 3 into 22 into 2. That's giving me 3168 centimeters. This is the surface area, whole surface area of the pipe with the given dimensions. Let us now move on to another question. This is one of a very common question, which we come across during the application of the surface area, the curved surface area of the right circular cylinder of a roller which is 1 centimeter long, 120 centimeter long, is 84 centimeter. If it takes 500 complete revolutions to label a playground, what do we have to determine is the cost of labeling the ground at a rate of 30 paise per square meter. Now, because when the roller is rolling, that is only covering of the lateral surface area of the cylinder. So area covered by the roller in one revolution will be equivalent to the curved surface area of the roller, because when it is rolling, if I just try to imagine, if I draw it like that, this is when it is rolling the ground, right? So the part which is covering the ground at its when it is rolling once will be only this portion, that's the lateral surface area. So the lateral surface area or the curved surface area is given by 2 pi RH. So it is 2 into 22 by 7 into the diameter is 120. So isn't it? It says the diameter of the roller, so it is 60. Oh, sorry, into height is 84. Let me just make this calculation. It's giving me 31680 centimeters square. This is in one revolution. Now it says it takes 500 such revolutions to level a playground. So the area covered by this roller, which is rolling in one roll, it is covering 31680 centimeters square. So in 500 revolutions, it will cover 31680 into 500, right? So that is covering up, let me just convert it into meter square. So whatever I'm getting, that will be divided by 10,000 will give us a meter square, and that's I'm getting to be 1584 meters square. This is the area that that roller is covering to level it. Now this at a rate of 30 paisa, so 0.30, it's giving me 475.20. So 475.20 is the cost incurred to level the ground by this roller, which is in a 500 complete revolutions. We will be taking up more such questions in the next few sessions. Thank you.